Risk. Today we'll be investigating risk and comparing the probability of two events occurring. We'll be focusing on 5 different scenarios and backing up our answers with research and our own data collection.
In our first scenario, we wanted to investigate and compare the probability of
a coconut hitting someone on the head and killing them, or being killed by a shark.
Before we started investigating, we hypothesised that you would be more likely to be killed by a shark. To get the best possible data, we decided to research this data online. Unfortunately, we were unable to find any real statistics based on data for coconut deaths. However, we did find an estimate for this statistic on a website named paradise.castaway.com. It claimed that on average 150 people were killed per year worldwide from falling coconuts. We went on to find average worldwide shark deaths. We found a statistic for this on floridamuseum.ufl.edu, which based on records stated that we have an average of six shark deaths worldwide. We put this data into Excel and produced these graphs which are on screen now. This graph isn't perfectly accurate because of our coconut statistic not based off of real data, but you could use it as a rough graph.
For our next scenario, we wanted to collect data from the Year 8 students at Westminster School. So we agreed on investigating if you were more likely to be
1. Food poisoned or getting concussed as a Year 8 Westminster student.
As a group, we hypothesised that you would definitely be more likely to have a concussion, as Westminster is a sporty school. To begin, we started by walking around the whole school at lunchtime and surveying as many random Westminster Year 8s that passed by as possible to collect a sample survey. We managed to survey 25 people. We then added up all the number of concussions and food poisonings to make a total of 33 injuries. Next, we divided the number of concussions by the total amount of injuries, which was 9 divided by 33, which equaled 0.27 or 27%. We repeated the same for food poisonings and turned this data into a pie chart and a bar graph. The graphs on the screen now could be made more accurate if we surveyed more people from Year 8 or even conducted a census of all the Year 8s.
For our next scenario, we wanted to look at more shark deaths as we found them interesting, so we compared
Die falling out of bed or being killed by a shark.
Before we started any research, we hypothesized that shark deaths would be a lot higher than bed deaths. We began the search for any data that would relate to average yearly bed deaths. We found some data on westlawn.com for the number of bed deaths in 2011 Australia, which was 58. To make the data collection fair, we went to find the shark deaths in 2011 Australia. According to National Geographic, there were 4 deaths from sharks in 2011 Australia, which is an outlier of data compared to other years of shark deaths. We used the same process as above and created Excel graphs. These graphs we made are accurate and are based off real data.
For our next scenario, we wanted to collect data from the Year 8 students at Westminster School. So we
Electrocuted or break a bone as a Year 8 Westminster student.
As with our other scenarios, we begin with a hypothesis. We all agreed that you have a much higher chance of being electrocuted than breaking a bone. As before, we asked the same random 25 Westminster Year 8s how many times in their lives they have been electrocuted or broken a bone. We then made our total number of injuries and divided the number of each injury by the total to get a percentage for each injury. These graphs are accurate and the information in the graphs reflect off the Year 8s as Westminster.
For our final investigation, we wanted to compare weather. So we chose lightning and compared the probability of
being killed by a lightning strike or from a plane crash.
As we don't have many plane crashes in Australia, we predicted that you would have more chance of being struck by lightning and killed than killed in a plane crash. Unfortunately, we couldn't find any real data for lightning deaths. 374 fatalities from plane crashes in Australia over a 10-year period, which equals an average of 37 plane crash fatalities per year. The graphs on the screen don't have all the statistics based off the real data, so they aren't accurate enough to use as an official information for something like government use.
The data we collected and graphs we made were mostly accurate enough to use for official purposes, but some wouldn't be appropriate to use officially, as some data were only estimates. Our results and hypothesis were generally not the same, though some of them did align with our hypothesis. The type of data we collected was discrete numerical data, and we chose to display our information on pie charts if they were percentages, and bar graphs if it was a number. In conclusion, this was a great learning experience as we got to use our understanding of probability and statistics practically to investigate risk. We hope to conduct another investigation like this in the near future.